Welcome everyone to the Human Factor, Cohesity's weekly interview series. I'm Patrick Redknap and I am joined today by Mr. Thomas Bryant. Thomas, how are you?
I'm doing great.
Good. Would you like to introduce yourself? Tell us a bit more about what you do, what your background is, and then we can move on to the more human element of things.
Sure. Yeah, I'm a senior product line marketing manager at VMware. So I work in the cloud management business unit. So I focus mostly on like operations products like vRealize operations and Log Insight and things like that.
Sure. So that obviously shows you have a good grounding in technology, but we're here today to talk mainly about more about humanity.
Yeah.
And something brought you to us was your 3D printing, something that you've been quite vocal about on social media, but it is more about you printing PPE for the COVID-19 crisis. So would you like to tell us how you got into that? And
Yeah. So I mean, when the whole COVID-19 thing happened, I got some sort of mysterious illness, and I need to actually go in and get the antibody test. But I don't know what happened to me, but I certainly got wiped out. And I've got a lot of friends in the medical community, doctors, nurses, frontline responders, and just kind of going on Facebook. I had nothing else to do. I was sitting in bed. I couldn't really get out of bed. I was isolated from everybody. And everybody was crying for help about PPE. They couldn't get masks. They had nothing. There were nurses wearing trash bags, and there were a couple different 3D printing community groups on Facebook, on Discord, and things like that were starting to figure out, hey, what can we do to help? We've got all these 3D printers. We've got plastic. What is something that we could do to help? And as they started kind of coming up with designs, they started spreading those out and saying, hey, make these, use them, do whatever you can to help your community, help the world. And so I just started printing them, these little face shields, which actually, see if I have any of them around. I had one here. Oh, there it is. So, I mean, it's the most simple thing in the world. There's a couple different designs, but this one is from 3D Verkistan. And there's like a Prusa model and a couple others. And, it was just like, oh, hey, this is something super simple, very cost effective. I mean, I think it costs like, actually, I think the transparency costs more than the plastic to make this. And I just started printing them. And then I actually didn't know how to get them to people. So I just put out a post on my local community. I talked to my friends and said, hey, how many do you need? But I talked to just on Facebook, hey, does anybody need these? I'm not going to charge you for them. I don't care. Like, I just want people that are out there, doctors, nurses, firefighters, police officers, to get them. And in a week, I had 800 people, or not 800 people, but orders, I guess, if you will, for 800 of them. And I just started printing.
Wow, that's a lot of orders. So I guess were you trying to keep up with demand? Did you feel kind of obligated to produce more at a rapid rate?
Yeah. I mean, absolutely. And actually, from that post, I got connected through somebody who was in the well, I live in an area called Lakeway, Texas, which is just outside of Austin. Somebody in our Lakeway kind of group pointed me to a group called Masks for Docs, and so I got connected with that group. And that's where I found out the bigger kind of opportunity just for getting this to all the hospitals. So they were starting to get connected to all the hospitals. But yeah, I mean, it was, hey, let's produce as many as we can. But I only have a single 3D printer at the time. I actually have gotten another one since then. But I could only print 2 on a bed at a time. And so one of the things that I was trying to figure out is, well, I could print 2 at a time, and that's great, and I could do that, essentially every hour. But then when I go to bed, at midnight or so, and wake up at 6, there's a span of time that I could print 2, but could I print more? And so about that time, that's when I started working on the idea of stacking them, and basically taking this simple thing and just start making stacks of them, and finding a way maybe to separate them after the fact. But still, I think the hardest part in that was just finding quality of making these. Doing one is pretty easy, but stacking them and then having them split to where there aren't gaps and cracks and things where virus could get in was actually pretty difficult.
So you went kind of down the Airfix route, where all
Yeah.
the parts click together. You just snap them off and sand it down.
Yeah, yeah, and actually, I mean, I got to the point where I was doing this, and Eric, the 3D Verkistan, the gentleman who created these, I worked with him. He was doing some iterative design on these visors, and he helped me quite a bit with that. And I finally got to the point where I could get like a decent stack of 10, 20, 30 of them tall. And again, it's kind of with 3D printing, it's sort of like IT. It all depends on what you have and how you run it. But yeah, I mean, my goal was I wanted a stack of 20 that would be the same quality of this with essentially no extra work other than separating them. And that's what I got to. I can print off giant stacks of these. It's not faster, it's actually slower, but the whole idea was in that downtime where instead of getting 2, I could get 10 or 20.
Less effort, more speed, basically. Well, not necessarily more speed, but less effort, kind of streamline the process.
Yeah, exactly. I mean, it just made it more efficient. And actually, some other people have come up with even kind of more novel ideas in a way. Some folks are actually using their printers now, and instead of doing stacks, they're having it print like 1 or 2, and then they're making a process where it actually like swipes it off the print bed, and then it starts the whole thing over again. So there's a lot of really creative folks out there trying to come up with ways to make these visors as quickly and efficiently as possible.
Well, I guess it's kind of the opportunity during a lockdown situation where you can geek out a bit more and try and like make the perfect solution for a problem.
Yeah, I mean, absolutely. I mean, in my spare time when I'm not doing 3D printing, I'm usually volunteering with our local nonprofit soccer club. So we've got about 1,200 kids that play soccer. Both my boys play, and so we're usually pretty busy with that on every night, every weekend. So during this downtime, it's nice to be able to have something else where I can focus a lot more on the family. But when the kids go to bed or whatnot, and during the day when I'm just doing normal work, I can print off visors and things and then send them out to help folks.
So one thing I was going to ask you about this, because my brother's doing this on a smaller scale than you are, but it's like he told me he had problems with people taking them because they weren't to code or they weren't like the right ones. So some places will only accept certain visors and stuff like that.
Yeah, it's very true. And that's kind of the thing when when I was working with individual groups was, I had I sent them like, hey, this is the visor that I'm generally printing. Will this work for you? Because we have some hospitals locally, and there's some like I've sent some of these to New York and Seattle and stuff. And I want to make sure that this is the right design. The easy thing, or at least the nice thing, is that a lot of the designs are actually NIH approved now. So they've gone through like the NIH like emergency approval process. And so it's really just a matter of making sure that whoever you're working with, that you communicate, hey, this is the design I'm doing. Is this what you need, or what do you need? Is it the Prusa one? There's one that has like a visor kind of up above it. And then there's like the 3D Verkistan. There's a bunch of other ones. So it's just making sure that whatever one you are making, that they want them. But even then, I have different qualities even within this. Like this one you can't see it on the video, but there's some holes in it. And so when I send these to groups, like Mass for Docs, I'll have a bag that has like single use, right? So this one, instead of just throwing it away because it has a hole, it's still useful, but you couldn't really clean it like you can the other ones, versus the other bags that are reusable, so you can wipe them down with alcohol or disinfect it. So yeah, it's interesting because there's lots of different groups and lots of different people that want different things.
So it's more about communicating with who's getting it, and then you can kind of almost make it for them specifically, or say, right, well, if they need 60 and they've told me they need these ones, you can make them.
Yeah, exactly. Yeah, I mean, it really is on-demand, small-scale manufacturing, right? The whole goal, really, in all of this is to be a stopgap, because it takes me 30 minutes roughly to produce a visor. If this was being injection molded, it would be seconds, right? But to produce one of those blocks, to produce these, takes tens of thousands of dollars, and time to machine it and all those other things. So the goal and hope is that we can fill that stopgap until either somebody decides to make this particular thing, or the PPE ramp from 3M and everybody else can catch up.
Yep. So the way I understand, I'm going to move a bit more into kind of the technical area of how you produce these. So
Yeah.
the way I understand it is you have a spool of filament, and that
Mm-hmm.
runs to the printer, and then the printer uses that filament as kind of the building block for the 3D printing itself. Now,
yeah.
I've heard that when it goes wrong, it can go wrong spectacularly.
Oh yeah, it definitely can. I've got some prints in the trash out there actually. So when we've scaled back, or I've scaled back visors a little bit. We're doing pretty well here in Austin. So we're producing a little bit less than what we normally do. So I've got a second 3D printer now, and I'm printing some Mandalorian armor, as one does for their children. And so I've been printing some of that. I've got some on there right now, but yeah, when like if you don't get proper bed adhesion or it pulls apart, yeah, you can get spaghetti and a nightmare. And because it's a hot block, like right now, it's printing at 220 degrees Celsius. The bed temperature is 110 degrees Celsius. It can turn into a big blob of molten plastic that can ruin a print head. I mean, that can definitely take you out for a while you chisel that off.
Yeah. So yeah, I mean that's what I heard. I heard it's just like you literally will have to almost take apart the printer to fix it sometimes.
Oh yeah, yeah, absolutely. And I've got a couple print heads. I mean, I've been doing this for a while, so I have different print heads with different nozzle sizes on them. So, but yeah, for like the printing I do, there's two main types. There's FDM, which is where you're basically adding layer by layer, and then there's like resin, where it's essentially hardening a resin and it rises up out of a pool of resin. But for FDM, there's different nozzle sizes. So I can print like this visor. If I print it on like a 1.2 millimeter nozzle, I can print this in like 15-20 minutes. But if I print it on a 0.5 millimeter nozzle, it's going to take 45 minutes or more to print that same thing. So I've got different print heads with different nozzles. I've got two print heads that are torn apart right now because they're broken. From that very thing where I got a filament thing and it just everything stuck together, and it's not pretty.
Well, I mean, so obviously this is a thing that's happening in the world now, where people can contribute from their own home in some small way to helping their local health centers, helping their hospitals, wherever. So the next point I was going to move on to was, what's the best way? If someone wants to do this, what's the best way to get started? So if say if me, I don't have any of the kit, just got my computer at home.
Yeah.
How do I begin?
Well, I mean, I would say the first thing actually is to join like a local group, right? Try to find a group or join something like Masks for Docs. There's different groups in different countries. So if you hop on like, I use social media quite a bit. So you can either hop on Twitter, hop on Facebook, and you find a 3D printing group. Look for like PPE or Masks for Docs or something like that. Masks for Docs has groups in every major city, I think all over the world. And maybe that's the right group, but there might be another local group in Austria or Australia or wherever that you can just kind of search out on social media, and from there kind of decide, what if you want to help. Maybe it's a printer, right? Maybe you want to go out and you can buy a printer. You can get a low end printer that can still print quality, like an Ender, for a couple $100. And you can get that in a week or so. You can assemble it and start printing. But even there, maybe you're not comfortable with doing 3D printing. There are folks that are doing other jobs like logistics, right? Instead of everybody taking all of our masks downtown, they've got folks that, hey, I want to help, and they'll drive around and contactless pick up all the masks and all the visors and things that we produce, and then they take those downtown, or they'll deliver them to the hospital. So there's other people that are bagging and getting all the materials ready and putting in packing slips and that sort of stuff. So there's lots of different ways, I think, for everybody to get involved. It doesn't have to be technical, but if you're up for it, It's a great way to get in there. And the community for 3D printing, we're great. I mean, it really is a family. And you get a printer up and running. We've got different Slack channels, like for Master Docs, for 3D printing help. We'll help you get started. We've got all the designs. We literally have onboarding docs, right? Like you do at a company when you bring somebody new in. Here's the models that we use. Here are the settings that work really well for different types of printers that we typically see people have, and then we kind of roll from there.
Yeah, so I mean, I guess there's enough people out there to steer in the right direction, and if you can go on these sites, they'll be able to tell you where to start. So that's step one.
Yeah.
You got the information. But another good question for that would be, I mean, what's the average startup cost for it? I mean, how much have you got to put in for your kit?
Yeah, I mean, like an Ender 3, maybe $300, $400 to get into, to get the printer, and then filament costs can vary, but typically most people are printing them with PLA or PETG. Most people prefer PETG just because it's a bit easier, or it's a little bit more durable filament, and easier to sanitize. Those run about $20 to $30 a spool, and out of a spool of filament, you'll usually get about 50 to 60 of these visors. So, for about $450, you'll be producing your first sets of masks. That said, groups like Master Docs and a lot of these local groups, they're working on getting donations. There are 50, like in the US, it's called a 501c3, which is a nonprofit organization, and they're providing filament to a lot of the printers at no cost. We're using our machines, and they're getting donations to pay for the filament. So really, it just costs us electricity.
Okay, well, so yeah, that will be part of, I guess, joining. They would be able to get you the filament out to you, and then you could just print with that effectively.
Yeah, hopefully. I mean, I'm one of those outliers. I have a printer that uses 3mm filament, and they don't really have any of that. But I've actually had a lot of friends that have said, "Hey, I'm not going to buy a 3D printer, but I want to help. Can I just send you $20?" And so they did. So I had a bunch of people just send me some cash, and actually, one of the really cool things that I was able to do with that is use that through my company has a matching program for donations. And so I was able to actually take a lot of that and then donate it to like Master Docs, and I can donate it to different groups. So that money can then get to those groups who can then provide filament back to me or to whomever. And basically it doubled up what those contributions were, which is pretty awesome.
That's awesome. So that would probably be VMware doing that then, I'm assuming. Saying, yeah.
Yeah, for me it was VMware, but a lot of companies have matching through things like Bright Funds. Bright Funds is like a site you can go to and find like charities you can contribute to.
Cool. Well, I do have a little note which I think I have to shoehorn into there right now, because you were talking about the quality and you were talking about various materials. So you said there were two main materials that you would use. There's obviously a preference for the one that is sanitized more.
Yeah.
So was it PPG you said? Yeah.
It's called PETG. It's polyethylene terephthalate. I can't pronounce that last word.
Okay. But
yeah, it's PETG.
Okay, so you would use that, but I have heard that you can pretty much print multiple materials on top of that. So if you need like a more robust design or anything, you can print. I've heard you can print metal. Is that right?
Yeah, well, sort of. I mean, there's lots of different materials you can print. So, like right now I'm printing some stuff in ABS, which is why it's out in my garage, because it produces nasty fumes. But ABS plastic is like the same kind of plastic that you find in parts in your cars. It's really durable. It's great for outside. It's very heat resistant. But that kind of plastic doesn't do so good on your skin long term. So what you're generally looking for is things like PLA, PETG. Those are generally considered like skin safe materials. But yeah, there's different types of things like TPU, which is a flexible filament. I have carbon fiber, nylon filament. There is metal infused filament. There's wood infused filament. Metal gets a little weird. Like there's some that are like infused copper and infused silver filaments, but there haven't been any like studies that have actually shown like what the true antimicrobial qualities of those are. at least I haven't seen them, so I could be totally wrong. But yeah, there are some that do that, and then there are actually some that do print full on metal. And what you do is you print it on your printer. It's a high temp thing, and then you send it in, and they'll sinter it for you, and actually turn it. Basically, they heat it up and turns it into a real, honest to goodness metal, metal whatever, like you would produce off of a CNC machine.
So I guess that the really kind of the health ramifications of 3D printing in general for healthcare settings, I guess we might even be looking at a future where they might even have on-site printing in the future, where they can just produce their own stock and get the filaments in.
Yeah, and actually, there's a bunch of hospitals doing that today. So, in the need for like ventilators, a lot of hospitals have been iterating on designs of how they could share ventilators, and they've got 3D printing. So there are bio 3D printers now that people are using and starting to experiment with how they could build like blood vessels and things like that. So, yeah, I think the future definitely is going to be a lot more of hospitals having 3D printers, both for bio and for mechanical purposes, whether it's plastic or metal or whatnot, to be able to, you can even take a CAT scan now, and you can get an STL file where you could like print a scan of your brain or whatnot. So imagine a future where you could, print a custom heart valve for somebody made out of metal and be able to put it in, within the same day. You don't have to send that off and have to have something, one size fits all. It's truly customized to an individual.
Yeah, I was having also a discussion about how the production of 3D printing, the larger the object, the longer it takes, obviously, because you're using more material. So
Yeah.
for medical usage and for implements or any type of prosthesis or anything, it's a shorter scale than you would expect to be able to send it off for customization anyway. So that
Yeah.
is why it's going to be applicable.
Yeah, absolutely. And a lot of those things are also designed to be somewhat modular, right? I mean, yes, it could, I'll use like a prosthetic hand, right? There are so many different pieces in there. The nice thing is that you wouldn't print that all at once anyway. So having basically a farm, right? A printer farm of multiple printers, to where each one could do, a different piece of like the finger and the joints and the sleeve for it, could all be done at the same time and actually produce something bigger in a shorter period of time, because you're again farming out smaller pieces to individual machines, right? You're breaking a big job into smaller jobs, right? You're batching things up.
Yeah, and I guess that would be, if you have your farm, you can just literally rock out the parts, and then your manufacturing can go on where you can put more parts in. So truly modular design for 3D printing is where we are right now anyway.
Yeah. I mean, and even me, I mean, like I never set this up to be a business or anything, but like I've had friends that have said, "Hey, can you print me this part for my immersion blender because it broke and I can't buy this part. It's like $50 on eBay. Can you print me one?" And they send me the dimensions in the picture, and I can mock one up. And he's like, "All right, I'll send you like a couple bucks." Thanks.
Yeah,
Why not?
I've been doing up an old Land Rover Defender, and literally I've been getting my brother to 3D print parts when possible, because, and the guys from Cohesity will berate me on this because they're always telling me off about it breaking down constantly, but that's where 3D printing comes in handy, because I've had a few points where I've said, I need this bit, I can't find it, or it's ridiculously expensive for a tiny piece of plastic. Can
Yeah.
you make it? Yeah, my brother will often say, no, but every now and
Yeah.
then I'll convince him.
Yeah. I mean, I would say the one other benefit that I've really enjoyed is that we as a society have really become a single use society. We use something, it breaks, we throw it away, we buy a new one. The ability of like a 3D printer to allow me to do more self repair on things. I did it just the other day with my son's microphone stand. His microphone stand broke in a way where nobody really sells that piece of where it broke, and so I could go buy a new one, which would cost $15 to $20, and they'd have to produce it, and it would get shipped to me through UPS and all the fuel and everything. Or I printed the piece. It cost me, I think it was like 35 cents, 32 cents to produce the piece that I needed. It works, and now his microphone stand works, and that kind of flexibility and that has been great. And then the other piece for me is I'm really trying to figure out how I can use this to start teaching the next generation of kids to start doing, whether it's 3D modeling or we can do it through Raspberry Pis and making, like little handheld gaming devices, and we can print those. There's lots of different things that we can do with this 3D printer to really get kids engaged in STEM activities, which is kind of my passion now too.
Yeah, so I would guess that in the future schooling, we might consider having like you've got wood shop, and then you might have printing shop as well.
Yeah, I mean, absolutely. My son, in one of his classes, in a GT class that he has, they have a 3D printer, and they do spend time on like Tinkercad. If you've never seen that, Tinkercad it's from AutoCAD, but it's a website you can go and basically model 3D shapes. I use that for basic design because I can mock something up. It's really drag and drop. It's simple. I can make gears and sprockets, and I made a Rick and Morty mask. So I made a Morty mask in Tinkercad. I mean, it's a sphere and a bunch of things. And kids can use that to make something and then print it in real life. That's pretty amazing to take something that you designed on a computer and then have a tangible object, in a few hours.
Well, that's one thing that kids want, isn't it? They want to be able to see it, they want to be able to design it, and they want to get it in their hands physically. They don't have to wait.
Yeah, I think more and more kids will get into that, and because printers have come down so much in cost, that barrier of entry will continue to decrease, and we can see more and more kids getting into it. And I think that for a lot of kids that are creative but maybe aren't the next sculptor, but they might be really good with a computer, it's another avenue for them to do something that's creative, or more engineering if they want to do that, or math. Because there's a lot of math in this stuff too, where you can go in and actually program it to make parts based off computational algorithms, right? I want to have this many gears and this sort of ratio, and you could program that, and it'll actually then make a 3D version of that for you. It's pretty amazing.
Yeah, that is really cool. So you could, I know the moving parts thing about it as well. You can print moving parts, so you can print an enclosed moving mechanical structure.
Oh yeah, absolutely. And you can print them like in single prints. I mean, so again, I'll go back to my kids. Like I've printed them lightsabers that basically can come out, like the kind that will extend out as a single print. But yeah, I mean, we've made all sorts of things. So again, he had a project where they were doing catapults, and they built their own catapults. But then we went on Thingiverse, which is a site where you can store models, and we found some catapults that some other people had designed, and we printed those and started playing with catapults and trebuchets. And yeah, there's some gear mechanisms. You can even print entire engines that actually can like move and hand crank and stuff.
So medieval warfare, is your next pursuit. There we go.
Oh yeah, they're launching Legos all the time.
So I've got two more questions to you. Then I'm going to move to see whether anyone else has got any questions. And these are really kind of very off topic. So the first one I wanted to ask really, well, it's not too off topic actually. I've heard about this. It's a Benchy test. What's a Benchy test? Do you know that?
The Benchy test. Yeah. So Benchy is a boat. It's a small boat that you can print, and the idea is when you're first getting started with the printer, the Benchy is something that will allow you to see the quality of your print. So it tests everything from like how well the print adheres to the bed, what the layers look like. It has some overhangs because you want to see how the overhangs print. It's got doorways and arches and things. So and small fine details as well. The idea is that if you can get a Benchy to print really well, then your printer's pretty well dialed in. There are other things that you can test before you get to the Benchy, right? There's a 20 millimeter cube or a flat surface to make sure your bed is at level and it's adhering right. There are cubes to make sure that your printer is printing like the right dimensions. But the Benchy is sort of like one of those de facto tests of, yep, everything's dialed in, everything is working, and if Benchy looks good, most of your other stuff is going to look pretty good.
Yeah. I heard it's like a steamboat Mickey kind of boat. It's a little steamboat.
Yeah,
right?
Yeah. Yeah, it's very much like a Steamboat Willie.
Fair. Okay, I just really wanted to clear that up because I've heard people talk about Benchy. I'm like, what is a Benchy? I could probably Google that, but I've never bothered to.
Yeah.
All right. The only other one is apparently, this is one thing my brother said to me. He said that you haven't officially be 3D printed unless you printed a Groot.
I'm not. Yeah, I guess I'm not a. I have not officially printed. I've printed all sorts of other things, but now I don't know. Groot's pretty interesting. I've actually wanted to do one. There's some really cool ones. Actually, the one I really want to do, there's a Groot Venom. So somebody remixed Groot and Venom and put them together. So if you ever like Google Groot and Venom STL, it's pretty cool. But yeah, I've never. No, I've done a lot of other things. Like I'm looking around my room, I've got all kinds of other crazy things I've printed, but I haven't done that one.
So before we take questions, I want to bring this up as well. You've got some Mandalorian armor down there. I don't think I saw it. Do you want to quickly show some of that?
Sure. So actually, this is a good example of when I ran out of filament. So this is a helmet. So it's printed as a single print, but you can see I ran out. So this is about 1 kilogram of filament down here. And then this is, I forget, I think it was like another 200 grams or so. So, I mean, this is a full-size helmet. Here, I can take it, put it on and whatnot. It's got lots of post work that needs to happen and whatnot. And that one, actually, I printed PLA. I've got smaller ones for my kids. You can see I'm starting to sand that one down. I've started making some Mandalorian armor. This one I haven't dialed in the other printer very well, but this is like 2 pieces of armor. So it goes on like that, right? And so I've started making armor for the kids. Wanted to be Mandalorians, shockingly, after watching the show for Halloween. So I've started producing it now so that I can actually sand it and print it. And then a friend of mine got me turned on to electroplating. So I'm going to take this armor, I'm going to sand it smooth, and then I'm going to paint it with a nickel paint, and then I'm going to electroplate it in copper, and then electroplate that with a smooth nickel plate so that it actually looks like real armor and it's actually metal on the outside.
That's taking it to the next level. You've got cosplay, and then you've got actual physical armor.
Yeah, that's the electroplating side. That's not even that's metal casting I'm getting into too. So actually, I've taken some of the pieces already and I've cast them in metal. They're out in the garage, but yeah, I've actually made like real tin armor.
All right. Well, okay. I'm going to open up to questions now. So anyone wants to give Thomas a question, please do drop it into chat. You could also get you on Twitter. It's Kix1979, isn't it?
Yes, it is.
It is. The year
it was so much cooler like 10 years ago.
All right. Let's see if anyone has any questions. Crickets at the moment, unless everyone's typing vigorously. Obviously, you've answered all their questions by the look of it.
Well, I always joke with people at work that I get paid a nickel a word, so I like to talk.
So I guess really for a question for me, it's like, do you ever really see a limit? Have you ever? Oh, here we go. I've got one from Mike. I'm going to ask you this question first. Have you had any limitations where you've wanted to print something and you've not been able to?
Yes. So the biggest limitation of a 3D printer is how big your bed is, in terms of the massive size. There is a Rick helmet on Thingiverse that I have wanted to print, and one, I think it's too big for my bed, and number 2, it's printed in multiple pieces, and I have yet to be able to get that to print successfully for me in those pieces, and I want that Rick mask. But yeah, I mean, I think that's the biggest problem I've had is there are some things that I've had to reevaluate how I want to do it because I can't fit it on my print bed, and then I just have to cut it up, and it's all right. Is it really worth printing? And then I just kind of forget about it. But yeah, I think that Rick mask is the one I want.
Persist. You need to persist. You'll get there.
Yeah.
So I've got a question from Mike Letchin here. He says, have you 3D printed anything for your whiskey hobby?
Ooh, I think I'm looking over there. If I have anything over there. No, I mean, I've got a lot of whiskey and bourbon. No, actually, I haven't. trying to think what I would do. I'm not sure what I could do for that, but no, I haven't done anything for that. I mean, I guess I probably do need to print something. I have like whiskey cubes, but they're just in like a plastic bag in the freezer. I need something a little bit nicer than that.
What you could print is, you can get those. They're like ice cube presses. I saw one of those when I was in Barcelona. You could kind of print the mechanism and then get a big block of copper or something. And you could do that.
Yeah,
ice molds. Yeah.
Yeah, I mean the plastic part wouldn't be so good for that, but if I guess if I electroplated it, I don't know. Yeah, that would be kind of fun.
Vic Camacho says he would like to see a Captain Morgan printout.
Oh yeah, I've seen that model. That would be a fun one to print out.
Yeah, man, that would be good. I've got a question from Wentz says Michelle. He says, "What is good middle of the road printer you can recommend for getting started?"
I honestly the Ender 3s and the Crealities are great. And they're relatively inexpensive. They're $300-400. And that's kind of the lower/middle ends. I'm a huge fan of Prusa. I don't have a Prusa printer, but I've got a lot of friends that do. They make a mini one and then they make the full size. That runs about, I think it's $750 to $1,000. And that's, I mean, I'd call that kind of middle of the road because they go up exponentially from there. I mean, like Utilimakers can run you 10 grand or more. I have two Lowell's-bought Taz 6s, new. They run $2,500. I bought each of mine actually used off of eBay for like $1,200, $13. So. And then as far as bigger bed, definitely better. And on most of them, you can upgrade all the parts too, right? So you can always start with an Ender 3 or an Ender Pro, which has some upgraded parts. Just get used to it, start it, use it, and then you'll start upgrading it. You'll get like a BL Touch, which is a sensor that you can mount on the printer that helps you with leveling the bed and can computationally find out, oh, hey, your bed kind of tilts this way, and so it'll computationally figure out where it needs to be to make a quality print. So yeah, bigger bed is definitely a limitation, right? So it's only as big as the bed size is, but do you need like my Taz has it's 280, it's 280 by 280 by 250 tall. Millimeters, so it's like 25 centimeters, or is that right? Yeah, about 25, something like that. It's basically an 11-inch cube. It's nice because then I can print bigger things, but again, a lot of models, they separate stuff out. So like, for example, the Mandalorian gun that he has, where's that other piece? There it is. So like here, that's way too big. It's 6 feet long. So this is actually like 1-2 pieces. I'm printing another version of it for my kids. Like this is one piece. You could never print the whole thing on a bed. So, anything that's like 6 inches by 6 inches or whatever that is in non-freedom units is fine.
I got two and a half. I can't remember. 2.5 centimeters to an inch. I can't remember. So that's going to be what? That's going to be like what?
Yeah. So that's about right. Yeah, 280. Yeah, because my bed's 280 centimeters by, or something like that.
Yeah.
280 millimeters. Yeah, 28 centimeters.
There you go. 2.54. I've been told. There we go. So when I said 2.5, I was a fraction off.
My kid would kill me because my son, bless his heart, actually knows the metric system better than the American model. Thank goodness for him.
Yeah, I get that when people say what, like 8 sixteenths or something, or I've heard 30 sixteenths before. I've heard.
Oh yes.
Yeah. So thank you very much, Thomas, for coming on board, having this great chat, and I hope to speak to you again soon, all the way from the UK to Austin.
You're anytime.
Austin, you are.
Yeah, I am. Thanks for having me.
Okay. All right, great. Thanks a lot.